Hi guys, I Aziz welcome you to CoedMaster, and in this practical demo video, I will talk about all the most commonly used methods that we can call on linked list data structure. So please watch this video till the end. So let's get started. Alright guys, so let's begin this video with the very first question, that how to create a linked list. So guys, there are two ways to create a linked list. So the first way to create a linked list is call a linked list ll equal to new linked list. So we are creating linked list using new keyword and we are not passing any argument to its constructor. So this is the first way to create a linked list. So there is one more way to create a linked list through the existing collection. So let's say we have already existing collection like array list. So let's say we have already existing collection. So let's say array list L is equal to new array list. Okay, array list dot add 1. Okay, let's add few more elements to it, 1, 2 and 3. Now if we wish to create a new collection of linked list using the existing collection, we can simply pass the array list in the constructor of this linked list class. Now we are good to go. Our linked list is created from the array list and we can simply print it on the screen. Okay, let's run the program, and as you can see that all the elements of the linked list is printed on the screen. So there are two ways to create linked list. One, we saw that without passing any arguments to constructor, and second is through the existing collection. So here we are passing array list as a constructor to this linked list and we are done. Our linked list object gets created and we are simply printing it on the screen. So this is all about how to create linked list using two different ways. Now moving on, now we are going to see all the most common methods that we can call on linked list. So the first method we can call on linked list is add method. So add method is used to add elements to the linked list. Okay, so let's add few more elements to it, 1, 2, 3. So let's verify it by printing it on the screen. Run the program and you will see that all the elements of the linked list gets printed on the screen, 1, 2 and 3. Now the next method is ll linkedlist.add, and this is the second version of add method where we can pass the index and the object to be added. So this index is going to be the valid index. This means if there are 3 elements, so the valid index is going to be 0, 1, 2 and 3. So we can pass 3 as an index and 4 as an object. And if you run the program, you will see there are 4 elements printed on the screen. So guys, make sure that you cannot pass any random value here. The index should be a valid index. So if there are 3 elements, this is index 0, this is index 1, this is index 2, and the new elements is going to be added on the index 3. That is why we have passed 3 here and the element is 4. Okay, now let's see the next method, that is linkedlist.remove method. Remove method is used to remove the elements from the linked list. And the default implementation of linked list remove the first element from the linked list. If we want to specifically remove any element, so we can also pass the index here. So let's pass the index 3 here. So with this, it's going to remove element present at index 3, and that was 4. So 4 gets removed from the list and all the remaining items gets printed on the screen. Now the next method is going to be a set method. So set method is used to replace the element at a specific index. So let's say currently the element present at index 3 is 4. So let's replace the 4 with element 5. Let's run the program and you will see that the 4 gets replaced with 5 and we get 1, 2, 3 and 5. Now the next method is going to be a get method. So the get method is used to find the element at a given index. So give it an index, let's say 2. Now copy this get method, paste it here and run the program. You will see that the element present at index 3 is 3, because at index 0 1 is present and at index 1 2 is present, at index 2 3 is present. So that is why 3 gets printed on the screen. Now the next method we are going to talk about is index of operator. So let's call ll linked list index of object. So it takes object as argument and in return gives the index of the given objects. Let's run the program and see the index of object 2 is 1 because 2 is present at index 1. Now let's talk about the next method, that is isEmpty method. So isEmpty method is used to find whether the given list is empty or not. So let's call ll.isEmpty and run the program. It will give false because we have 4 elements in the list. Now let's call the next method, that is size method. Let's run the program and it will give the number of elements present at the given list. So currently there are 4 elements in the list. That is why the output is 4. So guys, by now I have showed you all the common methods that you can call on linked list as a list data structure. Okay. Now next we are going to see all the methods that are specific to queue data structure. And as we all know that linked list implements list interface and queue interface. So all the methods, so far I have showed you all the methods that are present in list interface. Now we will see all the methods that are present in queue interface. So let's replace this linked list with queue so that we can call all the methods specific to queue data structure. Okay. So let's add few elements to the queue dot offer. Offer method is used to add elements to the queue. So let's add one. Let's add few more elements to it. 1, 2, 3 and 4. So currently there are 4 elements in the queue. Okay. Now let's print it on the screen. System.out, give it a collection queue, run the program, and you will see that there are 4 elements in the queue. Okay. Now let's call poll function. So queue dot poll function, and what it does, poll function simply removes the first element from the queue. Why? Because queue follows FIFO policy. Okay, FIFO. And what happens in FIFO policy? The elements that adds first will be removed first. Okay, so let's run the program, and after calling poll method, the first element gets removed and we are left with only 3 elements, 2 and 3. Now let's call it once again. So in this case, the first and second elements will be removed and we are left with only 3 elements. So this is how poll function works. Now let's call queue.peak method. So peak method is used to get the first element of the queue. So out of 2 elements, the first element is 3 and 4. Let me recall once again. There are 4 elements in the queue. We have called queue.poll 2 times to remove first and second element from the queue, and then we are calling queue.peak. So out of 2 elements that are 3 and 4, 3 is the element present at the front of the queue. That is why queue.peak is returning 3 as the element. So these are all the methods that are specific to queue data structure. Now let's move on and see all the methods that are specific to deck data structure. Okay, so let's replace queue with deck. Let's make it dequeue. And as we all know that deck follows FIFO as well as LIFO policy. And what happens in LIFO? The elements that are added in the last will be removed first. Now there are few methods that are available as a queue data structure. So let's quickly add few elements to this deck. So let's call dequeue.offer first. Okay, offer first takes one object. So let's add 1 to it. Then call one more method, that is offer last. Offer last, give it a 2. So currently we have 2 elements. Let's again call dequeue.offer first. Let's give it 3 as object. Let's call it once again dequeue.offer last. Okay, let's give it 4 as element. Now let's print deck on the screen. Dequeue, run the program, and you will see that there are 4 elements in this deck. First one is 3, 1, 2 and 4. Now let's call the dequeue.poll function. Okay, poll first. So it's going to remove the first element from the queue. Let's call it once again dequeue.poll last method. So poll last method is used to remove elements from the last. Let's run the program, and you will see that prior to calling this method, we had 1, 2 and 3 and 4 in the deck. After calling this 2 method, we only left with 2 elements, that is 1 and 2. Why is that? So to verify it, let's write a print statement over here and run the program. So as you can see that prior to calling this method, we had 3, 1, 2 and 4 in the queue. And after calling poll first element gets removed, that was 3. And then again calling poll last is going to remove the last element from the deck. So we are left with only 2 elements, that are 1 and 2. So that is why we are getting 1 and 2 as the output of this print statement. Now apart from this, we have one more method, that is peak first and peak last. Let's call peak first and then let's call peak last. Let's run the program, and as you can see that after removing 3 and 4 from the deck, we left with 1 and 2, and the peak means the first element among 1 and 2 is 1 and the last element among 1 and 2 is 2. That is why 1 and 2 gets printed on the screen. So guys, these are all the methods that are specific to deck data structure. But we are not limited to only one data structure. We can use this deck as a FIFO data structure. This means the element that comes first will be removed first. Or we can use this data structure as a LIFO data structure. This means the elements that are added first will be removed first. So we can use deck as a queue as well as stack. So it's up to us. We have all the freedom to use linked list as a normal linked list, normal list, or a queue or a stack. So guys, I hope by now you have a good understanding of all the methods that you can invoke on linked list data structure. So if you have learned something from this video, then please hit the like button in order to make YouTube algorithm happy. Please subscribe to this channel and don't forget to click the bell icon so my friend you never miss any upcoming video. So this is all from my side. Thanks for watching. See you in the next one.